Well, first of all, yeah, very good morning, and that's very fantastic to be part of this and to tell you a little bit about what we're doing in the project. And I'll step back a bit from what Simon said, and then come forward again. And I see, Neil, thanks for your question there about the type of projects. That's something maybe I'll try and address in my talk. So I'm Steve Hallett. I'm Professor of Applied Environmental Informatics at Cranfield University, and I'm one of the two digital environment champions for NERC. So in a sense, straight away, I'll be bringing in a slightly different side to this. It's not just about infrastructure. There's a very strong environmental focus to our interest and our research as well. I'm working very closely with NERC in the area of digital research, infrastructure, and data. So it's that sort of combination of the hardware and equipment together with the data sets that meet our objectives. So, you know, there's a strong environmental focus to our work within UCRIC and in DAFNI. And what we see is a considerable interest really in the intersection of environmental objectives and digital capabilities, or digital approaches. And this is giving us a whole new generation of tools to gain insight into the processes that we're concerned with. And in a way, I think that we catch the zeitgeist, to use a phrase, quite nicely, because across all of the research councils at the moment, there's a lot of interest in this area. Of course, we see UKRI have just published their Statement of Opportunity in AI. And there's a big review of AI processes going on at the moment. The Alan Turing Institute have their Environment and Sustainability Interest Group. The Royal Society have just published their report on digital technology and the planet. There's launches of centres such as the Joint Centre of Excellence in Environmental Intelligence with the Met Office and Exeter, and of course the various urban observatories we've heard about, and we are one of those. The sort of themes that we're interested in are clean air and human health, flooding, resilience to flooding, drought resilience, and these marry up very nicely with the delivery plan areas in NERC, which are the healthy environment and digital environment. And themes such as biodiversity, ecosystem services, the ability of soils to sequester carbon, natural capital accounting, and so on. These are areas that we're interested in using some of these technologies to address. And we have a focus on let's call it a technological arc, as Brian outlined at the beginning, from at the beginning mechanisms to capture data, sensors in the field, edge computing to pre-process, data fusion and assimilation, bringing that data across into platform for structuring, conditioning, and storage. And then ultimately that data applied within modeling and analytical tools. And finally, the sorts of, Simon's just noted, the sorts of visualization and decision support outputs from that. So that arc is the technological focus of the interest in these environmental themes. And to do this, of course, we're recognizing the use of and application of a whole different range of types and sources of data. And it's the combination, the fusion and the assimilation of all of these different types of data that allow us to have some of these tools to apply. We need cloud services then to allow us to receive and hold and process and output these data. Simon noted an interest in technologies such as digital twinning. This is something that's of great interest in so many different sectors, and the environmental sectors are looking very closely at this at the moment. These sort of hybrid approaches then allow us to get a better understanding of the environment and the risks that are posed to that environment, ways of enhancing resilience, environmental resilience, both engineering resilience and environmental resilience, to try and understand the threats that apply to buried infrastructure, for example, to the built fabric of our world, as well as the natural environment. And of course, there's societal and economic benefits from this. And people talk about the democratization of data, when we start to assemble and bring together these data sets, that's a powerful force for good, we argue, adding value to investments and also trying to mitigate risks as we see it. There's a horrible phrase, optioneering. I'm not even sure that's in the dictionary, but I keep reading about optioneering. And the idea is that you can try different scenarios, try out different strategies on your digital twin of the system of systems that you're considering, characterizing uncertainty. So what we need then is mechanisms to hold all this data, and this is where DAFNI comes in. DAFNI is a powerful tool that helps us across that arc that I've mentioned. And in order to fully take advantage of these data streams that Simon's outlined, we need tools to characterize and manage those data sets. We need vocabularies that help us to normalize the definitions and representation of the data. We need taxonomies in order to classify, to interoperate data. And lastly, we need ways of looking at the linkages between different data sets that come together. And the phrase that we use here, of course, is the ontologies. So the ontologies are ways of trying to understand which data sets snap together with other data sets to allow us to address these environmental challenges that I've laid out. And a lot of the work that we, along with other colleagues in this area, are looking at are trying to follow the so-called FAIR principles of data access and data management. The putting in place as mechanisms for dealing, the F is the findability of data, so the metadata needed to locate and discover data, tools to make that data accessible, and DAFNI is offering us a whole range of accessibility options. The interoperability is very much linked to this notion of the ontologies that flow from this. I'll mention more in a moment. And lastly, the reusability of data, that DAFNI represents a repository which can be used for a whole spectrum of different modeling approaches. And I'm involved in a project led by Professor Liz Varga at UCL and a team working on infrastructure research ontologies, trying to understand the different types of models for data from framework level at a very high level down to specific application level ontologies, and trying to see how these can be applied to the growing body of data held within DAFNI. Now, so DAFNI itself then is giving us the tools to receive these data streams, to structure and hold that data, and a capability, as Brian noted at the beginning, for containerizing models. And we have all sorts of plans for developing some of our environmental modeling and applying it in this Docker environment that Brian noted, and a whole suite of workflow options then to allow us to visualize the data coming out in Jupyter notebooks, with mapping, with graphical representation, tabularized data, and so on. And one thing that's particularly exciting, really, just sort of coming to an end here, is the notion of virtual reality and augmented reality. And as Simon noted, both in our research and also in our Center of Doctoral Training, DREAM, which Simon touched on, we've had a lot of research looking at the use of virtual reality for trying to interpret and present alternative optioneering, I suppose, coming back to that horrible word. And part of our work in DAFNI will be to put in place some tools for 3D visualization of these environments, the ability to see the unseen, perhaps to use augmented reality to look under the ground, to see what's going on, and the sorts of modeling. Finally, the sorts of modeling approaches we use are things like geohazard models, trying to understand the impact of the environment on the built infrastructure around us, for example, the road networks, buried infrastructure, water pipes, communications, and so on. Simon mentioned the bat sensors. We've used biodiversity monitoring to try and capture points of the location of different animal species, and also water behavior. So using cluster analysis to look at smart meter data to try to infer the sorts of behaviors that people have. So that's a number of the sort of application areas that we're looking to now take forward with DAFNI. So I'll see there's a few questions. So I'll pause and stop. Thanks very much.